Assalamu alaikum wa rahmatullahi wa barakatuh. Dear students, today we are starting another exercise of surface area and volumes. Surface areas and volumes. Class 9th. Exercise we are starting exercise 13.4. Let's have question number 1. It says find the surface area of a sphere of radius. You need to find the surface area of a sphere and radius is given. Simple question. So we have a sphere. Let me draw a sphere. This is a sphere. This is a sphere of radius 10.5 centimeter. Radius is, this is your radius and it's 10.5 centimeter. You need to find the surface area of this sphere. Here, radius of sphere is equal to 10.5 centimeter. Therefore, total surface area of sphere, you know, it's equal to 4 pi r square. 4, then you can use pi 22 by 7. Yes, it's given that use pi 22 by 7 times radius is 10.5. Then you need to do the square. Let me use the calculators to solve this. It's 10.5 times 10.5 times 22 times 4 divided by 7. It's 1386 square centimeter, and that's your answer. You got it? Yeah. Similarly, you can do part 2 and part 3. The question number 2 is find the surface area of a sphere of diameter. Now this time diameter is given. So by diameter you can find the radius by dividing 2 to the diameter. So you'll get the radius and you'll apply the formula 4 pi r square, you'll get the result. Now question number 3, find the total surface area of a hemisphere of radius 10 centimeter. Total surface area of hemisphere, radius is given 10 centimeter, total surface area of hemisphere is 3 pi r square, and you'll get the answer. Use pi 3.14. Question number 3, I'll show you question number 3. You have hemisphere. Radius is given. How much? Radius is 10 centimeter. You need to find the total surface area of this hemisphere. Here, radius of hemisphere is 10 centimeter. Therefore, total surface area of hemisphere, you know the formula 3 pi r square. 3 times 3.14 times 10 square It says use pi is equal to 3.14. So 3 times 3.14 times 100, 942 square centimeter, and that's your answer. You got it? Okay, make a note. Now question number 4. The radius of a spherical balloon increases from 7 cm to 14 cm as air is being pumped into it. Find the ratio of surface area of the balloon in two cases. Radius of the spherical balloon increases from 7 cm to 14 cm. So you have a spherical balloon. Let's say this is one and this is another. This is one sphere, this is another sphere. This is actually spherical balloon. Now when air is being pumped into it, it increases, its radius increases from 7 cm to 14 cm. Now here radius is 7 cm and here radius is 14 cm. Now what you are going to do, find the ratio of surface areas of balloon. Find the ratios of surface area. Find the total surface area of this, then total surface. Let us say this is sphere 1 and let us say this is sphere 2. So you can write here radius of sphere 1, that's equal to 7 cm. Then radius, let's say it's r dash, radius of sphere 2 is 14 cm. Got it? Therefore, ratio, that means total surface area of sphere 1 divided by total surface area of sphere 2 is equal to total surface area of sphere 1 is 4 pi r square. Total surface area of sphere 2 it's 4 pi r dash square. Now 4 pi and 4 pi gets cancelled. Now r is 7, then you do square. R dash is 14, then do square. Now 7 is 49, then 14 is 196. So 49 by 196. You can divide it 49 ones, 49 fours, 9 fours 36, 4 4 1690. Yes, 49 ones, 49 fours. It's 1 by 4. Hence the required ratio is. Hence the required ratio is 1:4. That's your answer. You got it? Okay, make a note. Then after that, question number 5. A hemispherical bowl made of brass has inner diameter 10.5 centimeter. Find the cost of tin plating it on the inside at the rate of rupees 16 per 100 square centimeter. We have a hemispherical bowl. We have this hemispherical bowl, just like this. This is our hemispherical bowl made of brass, has inner diameter 10.5 centimeter. It's like this. This is the inner diameter. How much is this? 10.5 centimeter. Inner diameter of this 10.5 centimeter. Find the cost of tin plating it on the inside. So you need to consider it, you have to do the tin plating inside the bowl. So that means you are considering the curved surface area for this diameter of this hemisphere. Here diameter, inner diameter, let's say D, is 10.5 centimeter, which implies that inner radius R is 10.5 divided by 2, and that's 5.25 centimeter. Since curved surface area, write down therefore curved surface area of hemisphere, inner curved surface area, you got it? CSAI, inner curved surface area of hemisphere, that's equal to twice pi r square, and that is 2 times 22 by 7 times 5.25 square. Let me solve it. 5.25 times 5.25 times 44 divided by 7, so you have 173.25 square centimeter. Now it says cost of tin plating. Cost of tin plating per 100 square centimeter is equal to rupees 16. Therefore, cost, which implies that cost per square centimeter is 16 divided by 100, and that is rupees 0.16. Got it? Therefore, cost for 173.25 square centimeter is equal to 173.25 times 0.16, and that is times 0.16, that is 27.72, and that's your required cost. And the required cost is rupees 27.72, and that's your answer. You got it? Make a note. Let me show you one thing from exercise 13.3. Question number 5. Let me show you question number 5. Yes, question number 5 of exercise 13.3. There has been some problem for this question. What length of tarpaulin 3 meter wide will be required to make a conical tent? There is tarpaulin, and tarpaulin has width 3 meter, and this is length of tarpaulin. You need to find this. To make a conical tent, you made a conical tent out of this. Conical tent of height 8 meter. And base radius 6 meter. Base radius 6 meter. Assume that the extra length of material that will be required for stitching margins and wastage in cutting up is approximately 12 centimeter, and use pi is equal to 3.14. I'm told that there has been a slight problem in this question, so let us do it once more. Let us see. You have a cone, you have a conical tent, this is your tent. Now what you do here, first of all write down what is given. Here, length of, here breadth of tarpaulin. Breadth of tarpaulin is 3 meter. Length of tarpaulin is what we are required to find. Then height of tent is equal to 8 meter. Then is it radius? Radius, yes. Radius of tent, it is equal to 6 meter. Radius of tent is equal to 6 meter. Now let us find the slant height of this tent. Let's say it's L dash. Slant height of tent will be equal to square root h square plus r square, and that is equal to h is 8 square plus 6 square, that is 64 plus 36, that's 100, and that will give you 10 meter. So you got the slant height of 10. Now after that, let me rub this. Now you have slant height, that is 10 meter. Then there is one thing, you make this tent is made up of this tarpaulin. So I can say one thing, according to condition, area of tarpaulin is equal to lateral surface area of tent. Why? Because the base is not included in the tent. Area of tarpaulin is equal to lateral surface area of tent, which implies that now area of tarpaulin is length times breadth, and lateral surface area of tent is pi r L. Now L is pi r, it's L dash. Now pi r L dash divided by B. Are we good? Now let's come here. L is equal to pi r, which implies that L is equal to 3.14 times radius is 6 times L dash is 10 divided by breadth is 3. Therefore L is equal to, now use 3.14 times 2 times 10, it's 62.8. 62.8 is meter, yes. 62.8 meter. Now there is one catch. This is the length of the tarpaulin, but there is some wastage as far as the stitching is concerned, stitching of tent is concerned. There is some wastage. So the effective length, hence the required effective length, hence the required effective length is 62.8 minus 20 centimeter is the wastage. 20 centimeter is 20 by 100 because we are in meters, to 20 by 100 as wastage in length. Wastage in length is 20 centimeter. This is the wastage in length. So we need to get subtracted this 20 centimeter from the length. That's the effective length, because this is wastage in length. Yes. So that will give you 62.8 minus 0.2. 62.8 is my length. Let me do 3.14 times 6 times divided by 3. It's 62.8 plus 0.2. I need to add this one. Wastage in length is 20 centimeter. Now it says our length is 62.8 meter. This is our length. Now there is some wastage. Now what was the original length? What was the actual length? Wastage plus our length. Yes. Now wastage plus 20 centimeters. Yes, it's 20 centimeter. 20 centimeters, 20 by 100 meters. So you do like this. That will give you 63 meter, and that's your answer. Wastage in length is 20 centimeter. What was the actual length? This is our length including the wastage. You got it? So actual length was 63 meter. That is our effective length. So kindly make a note. Now we have now let us let's have the question number next of exercise 13.4. Question number 6. Find the radius of a sphere whose surface area is 154 square centimeter. Now you need to find the radius of a sphere. Surface area is given. Follow the formula of surface area of sphere, that's 4 pi r square Equate it to 154, you'll get the radius. The diameter of a moon is approximately 1/4 of the diameter of the earth. Find the ratio of their surface areas. Question number 7. It says the diameter of the moon is approximately 1/4 the diameter of the earth. Let us say diameter of earth is d. Let the diameter of earth, let the diameter of earth be, let us say d. Let the diameter of earth be d, which implies that, or we can write like this, then the diameter of moon be, because it says the diameter of the moon is approximately 1/4 the diameter of the earth. Then the diameter of moon be 1/4 d by 4. 1/4 the diameter of the earth. So it's d by 4. Find the ratio of their surface areas. Find the ratio of their surface areas. Now let us see how we do this. Which implies that radius of earth, what is radius of earth? Then if diameter is d, so d by 2, very good. And radius of moon, what is radius of moon? D by 4 by 2, that is d by 4 times 1 by 2. You got it? D by 4 by 2. D by 4 is the diameter, divided by 2, that's the radius of the moon. That is d by 4 times 1 by 2. That is d by 8. D by 8. So you have radius of earth, you have radius of moon. Therefore, total surface area of moon divided by total surface area of earth is equal to 4 pi r square is the surface area of sphere. 4 pi r of moon is d by 8. So it's d by 8 square divided by total surface area of moon 4 pi radius of earth d by 2 square. Good. 4 pi will go. You'll get d square by 64 times 4 by d square. Now d square gets cancelled. 4 ones, 4 16ths. So you got 1 by 16. Hence the required ratio is 1:16, and that's your answer. Make a note. Now question number next. It says a hemispherical bowl is made of steel 0.25 centimeter thick. The inner radius of bowl is 5 centimeter. Find the outer curved surface area of the bowl. 0.25 centimeter thick. Let me show this one. 8th. It's like a hemispherical bowl. We have a hemispherical bowl with some thickness. So you go like this. Hemispherical bowl of some thickness, and that thickness is 0.25 centimeter. So this thickness is 0.25 centimeter. This is your thickness. The inner radius of the bowl is 5 centimeter. Inner radius is Inner radius is 5 centimeter. Find the outer curved surface area of the bowl. You need to find the outer curved surface area of the bowl. Let us see how we'll do it. Here, inner radius, let us say Ri. Inner radius is how much? 5 centimeter. Thickness is equal to 0.25 centimeter, which implies that outer radius RO. Now what will be the outer radius? Outer radius is 5 centimeter plus 0.5. 5 plus 0.25, that is 5.25 centimeter. This is the outer radius. Therefore, curved surface area outer, it's equal to 4 curved surface area outer of hemisphere. Hemisphere, it's twice pi RO square. Do we have to take 3.14? No. So 2 times 22 by 7 times RO is 5.25. Then do the square. So of this, 5.25 times 5.25 divided by 7, so you get 173.25 square centimeter, and that's your answer. Make a note. Now a right circular cylinder just encloses a sphere of radius r. Ninth question. A right circular cylinder encloses the sphere. So sphere is inside the cylinder. It's like this. This is a sphere. This is a sphere. This sphere just encloses. This sphere is enclosed by the cylinder. You have like this. This sphere is enclosed in the cylinder. Of radius r. So sphere has radius r. If the radius of sphere is r, that means radius of cylinder is also r. Find surface area of the sphere, curved surface area of the cylinder, and ratio of area obtained in 1 and 2. Let us first find surface area of the sphere. Surface area of the sphere. Here, radius of base is equal to radius of cylinder is equal to radius of sphere. So all of the radii are same, that is r. You got it? Now let's have the first part. What is it? Surface area of the sphere, total surface area. TSA of sphere is 4 pi r square, and that's 4 pi r square because r is r. Part number 2, curved surface area of the cylinder, CSA of cylinder is equal to twice pi r h. And look, if this is completely enclosed in a cylinder, that means the diameter of the sphere will be the height of the cylinder. Are you getting? Diameter of the sphere is equal to height of the cylinder. Yes. So I can write 2 pi r, then h is the diameter of sphere. Diameter of sphere is twice r times twice r. That will give you 2 2's 4 pi r square. 4 pi r square. We got it? Now, third one is ratio obtained in first and second. Ratio of first part and second part is equal to 4 pi r square is to 4 pi r square, and that is nothing but 1 is to 1, and that's your answer. You got it? Make a note. So we are done with this exercise, Alhamdulillah. Now let's have another exercise. Exercise 13.5. So far, these 4 exercises were dealing with surface areas. Now the rest of the exercises will deal with the volumes. 13.5, question number 1. A matchbox measures 4 by 24, 2.5 by 1.5 centimeter. What will be the volume of the packet containing 12 such boxes? It's easy question. It's a matchbox. The dimensions are given: length, breadth and height, because the matchbox is in the shape of the cuboid. So length, breadth and height is given. All you need to do is just apply the formula for volume of a cuboid, that is equal to length times breadth times height, and that will give you 4 times 2.5 times 3, 1.5, and whatever you get the answer, then it says containing volume of 12 such boxes. If volume of one box is what you get from the multiplication, then you can do that again, multiply that answer with 12 and you will get the result. It's a very easy question. A cuboidal water tank is 6 meter long, 5 meter wide and 4 meter deep. How many liters of water it can hold? You just know one thing, remember one thing about that, the conversion from cubic meter to the liters, because question is in meters. So when you multiply 10 times 8 times, what is it? Sorry, 6 times 5 times 4.5, that is 30 times 4.5. 30 times 4.5. So you'll get 135. That means 135 cubic meter is your volume. But you need to convert that cubic meter into liters. Remember the conversion? 1 cubic meter is equal to 1000 liters. This is the conversion from cubic meter to the liters. 1 cubic meter is 1000 liters. Now if you get 135, you got on the calculators, 135 cubic meter is equal to 1000 times 135. That many liters are your answer. Or if you have to convert from cubic centimeter to liters, the conversion is 1 liter is equal to 1000 cubic centimeter, or 1 cubic centimeter is equal to 1 by 1000 liters. These are the conversions what you may use in this exercise. So remember the conversion, make a note. Okay, so you easily get the volume in cubic meters, then convert it to liters, and that will be your answer. A cubical vessel is 10 meter long, 8 meter wide. How high must it be to hold 380 cubic meters of liquid? Now again, it's an easy question. Length is given 10 meter, breadth is given 8 meter, volume is given 380 cubic meter. Now apply volume of cuboid, length times breadth times height is equal to 380. Equate that to the volume of cuboid, that is 380. Now length is given, breadth is given, so you'll easily get the height. That is like something like this: 10 times 8 times h is equal to 380. So h is equal to 380 divided by 10 times 8. So you'll get answer easily. Now question number 4, find the cost of digging a cuboidal pit 8 meter long, 6 meter broad and 3 meter deep at the rate of rupees 30 per cubic meter. Again, just get the volume by 8 meter by length, breadth, height. 8 times 8, 6 times 3. So you'll get the volume. Now after that, cost of digging per square meter, per cubic meter, sorry, because volume is in cube. Cost of digging per cubic meter is 30. And what you would have got the volume, multiply that with the 30, you'll get the cost of the whole digging. Question number 5. The capacity of the cuboidal tank is 50,000 liters of water. Find the breadth of the tank if its length and depth are respectively 2.5 and 10 meters. It's again the same as question number 3. But before you need to convert this, let me show question number 5. See how it works. Question number 5 says the capacity of the cuboidal tank is 50,000 liters. Capacity means volume. Here, volume of, is it tank? Volume of cuboidal tank, yes. Volume of tank is 50,000 liters. Now convert it to cubic meters because rest of the dimensions are in meters. Convert this. As I told you that 1 cubic meter is equal to 1000 liters. So these much liters, 1 cubic meter is equal to 1000 liters. So 1 liter is equal to 1 by 1000 cubic meter. This much liters is this 50,000 divided by 1000. So you are now in cubic meters. Now that is 50 cubic meter. Now length is given. Find the breadth of the tank. If the length and depth are respective, length is 2.5 meter. Length of tank is 2.5 meter. Breadth of tank is 10 meter. Breadth of tank is, yes, breadth of tank, sorry, breadth is what you need to find. Depth is given. Height is 10 meter. Let's say edge is 10 meter and you need to find the breadth. So you go like this, since volume of tank is equal to LBH, which implies that volume is given, it's 50, length is given 2.5 times breadth is unknown, edge is given 10. So you go 10 ones, 10 fives, then you go 5 is equal to 25 by 10 times B, 5 ones, 5 fives, 5 ones, 5 twos, therefore B is equal to 2 meter. So that's your breadth, that's your answer. You got it? Now the next question says, a village having a population 4,000 requires 150 liters of water per head per day. It has a tank measuring 20 by 15 by 6 meter. Find how many days will the water of this tank last? Let's have question number 6. A village having a population 4,000. So population of village is 4,000. Here, population of village is 4,000. requires 150 liters of water per head per day. One per head per day means one person in one day requires 150 liters of water. So the requirement of water per day per person is equal to 150 liters. 150 liters. Now convert this in cubic meters, or there is no need. Keep it as such. 150 liters. It has a tank measuring. There's a tank. Length of tank. Length of tank is 20 meter. Breadth of tank is 15 meter. Height of tank is how much? Height of tank is 6 meter. Height of tank is 6 meter. Let us find the volume of tank. Therefore, volume of tank will be length, breadth, height, that is 20 times 15 times 6. And what you get? 20 times 15 times 6. So you got 1800 cubic meters. Now 1800 cubic meters is the volume of this tank. Convert this in liters. 1800 times 1000. You'll get 18. 1, 2, 3, 4, 5. 18 lakh liters. Is it 18 lakh? Yes. 18 lakh liters is the volume of tank. 18 lakh liters volume of tank. Now for one day, what is the consumption for one day? This divided by this. Consumption of one day. See. Now consumption of water per person. Consumption of water per person per day. Per person for one day. Consumption of water per person. For one person, what is the consumption for one day? That is 150 liters. Requirement per day per person, 150 liters. So that is consumption of water per person for one day is 150 liters. Got it? Then consumption of water for 4,000 persons, because we have 4,000 people. 4,000 person for one day is equal to 150 liter times 4,000. 150 times 4,000, and that is how much? 150 times 4,000 is 6 lakh. 6 lakh liters is the total consumption for one day. What tank has total storage of 18 lakh liters, and the consumption for one day is 6 lakh. So how long it lasts? So this divided by this, very good. So you'll do, hence water lasts for 3 days. Water lasts for 3 days. And that's your answer. Check the answer. You got it? Make a note. Now, question number 7. A go down measures 40 by 25 by 10 meter. Find the maximum number of wooden crates, each measuring 1.5, 1.25, 0.5 that can be stored in the go down. Find the volume of the go down, then find the volume of the crate. Now divide the volume of go down with the volume of crate. That will give you the total number of crates. That will give you the total number of crates that can be stored in the go down. It's easy. A solid cube of side 12 cm is cut into 8 cubes of equal volume. What will be the side of the new cube? Also find the ratio between their surface areas. A solid cube of side 12 cm. We have a cube, solid cube. Let me show you a question. We have a cube, a solid one, just like this. This is a solid cube. Now this solid cube is cut. This has a side 12 centimeter. Let's first write this. And this solid cube is cut into 8 cubes of equal volume, small cubes. This is cut into 8 cubes. This cube is cut into smaller 8 cubes. 8 such cubes. 8 cubes of equal volume. Equal volume. And we don't know the volume, but we know one thing, that the volume is equal. What will be the side of the new cube? What will be the side of this cube? You need to find this thing. This is a question. Also find the ratio between their surface areas. Find the ratio between their surface area. Surface area of this divided by surface area of this. Now first of all, let's find the side of this. You know one thing, that here length of, let us say this is length of cube, length of original cube, is 12 centimeter. Got it? According to condition, volume of this cube, volume of original cube is equal to 8 times volume of formed cube. You got it? For the new cube, you can say volume of formed cube or volume of new cube. Let's write volume of new cube because the question says what is the side of the new cube. So let's say it's new cube. Volume of new cube, which implies that you know the formula for finding out volume of cube, that is L cube. So it's L cube is equal to 8 times volume. Let's say it's L dash, then cube. Which implies that L we know, it's 12 cube is equal to 8 times L dash cube. Now you get 12 cube divided by 8 is equal to L dash cube. Now you can solve this. 1 divided by 8, so you have 216 is equal to L dash cube. Now 216 is nothing but 6 cube is equal to L dash cube. Now cube and cube goes, therefore L dash is equal to 6. Is it meters? Is centimeter. So 6 centimeter is the 6 centimeter is the side of the new cube. Now find the ratio of their surface areas. Is it total surface areas? Find the ratio between the surface areas. Yes. Now total surface area of original cube divided by total surface area of new cube is equal to what? Total surface area of cube is 6L square divided by 6L dash square. That will give you 6L is 12 square divided by 6 times L is 6 square. Now 6 and 6 gets cancelled. This is 144 divided by, or you can write like this, 12 times 12 divided by 6 times 6, 6162, 6162, so 2 2s is 4 divided by 1, hence the required ratio is 4:1. Hence the required ratio is 4:1. So that's your answer. Now question number 9. It says a river 3 meter deep and 40 meter wide is floating at the rate of 2 km per hour. The river is 3 meter deep and 40 meter wide, flowing at the rate of 2 km per hour. How much water will fall into the sea in a minute? So you have a river which is 3 meter deep and 40 meter wide. So height of the river, and so you go like this. Height is given and depth is given. Here breadth of river is equal to breadth of river will be treated as, here width of river will be treated as breadth of cube wide, and that is how much? That is 40 meter. 40 meter. Then we have depth of a river, that will be treated as height of cube wide, and that is how much? That is 3 meters. So it's 3 meter deep. It's 3 meter. Now water is flowing at the rate of speed of water. Speed of water. It's equal to 2 km per hour. 2 km per hour. This is the speed of water, 2 km per hour. How much water will fall into a sea in a minute? That means you need to find the volume of water in this for a minute. Now, therefore, volume of water per minute is equal to LBH. That will be equal to, what is L? Length is what we don't know, but we know one thing, that length is a distance, and distance is equal to speed multiplied by time. So instead of L, I can write speed times time. Speed multiplied by time, then times breadth times height. Keep it as such. Now what is the speed? Speed is 2 km per hour. Let us convert this 2 km per hour into meter per minute, because we are required to deal in minutes at the end of the day. So 2 km per hour is 2 times 1000 divided by 2 km is 2 times 1000 meters, and 1 hour is 60 divided by 60. That will give you 0 0 cancel, 2 1s, 2 3s, 100 divided by 3. 100 divided by 3 meter per minute. Divided by 3 meter per minute. So this is your speed. Now speed is 100 divided by 3 times. Time is per minute. So 1 minute, so 1 times. Breadth is 40. Then times h is, what is h? 3. Now 3 and 3 goes, you'll get 4000. So you got 4000 cubic meter. 4000 cubic meter. And that's your answer. So volume of water per minute is 4000 cubic meter. Hence, the required amount of water, hence the required amount of water is 4000 cubic meter, and that's your answer. Make a note. See you next time. May Allah subhanahu wa ta'ala bless you all. Assalamu alaikum wa rahmatullahi wa barakatuh.